So in this video, what I want to do is I want to take you through the steps of how to write the formula of an ionic compound. So how do you write the formula of an ionic compound? To do that, we are going to use a system called, that I call in reference to some old music of mine. There were two guys named Criss Cross, and I like to salute them as 90s hip-hop masters, Chris and Chris, and their band was Criss Cross. The Criss Cross method is what we use in my class in reference to the band that gave us such hits as Jump, Jump. And they use two names. They use their hip-hop names of Mac Daddy and Daddy Mac. The Criss Cross method, named in their honor, I'd like to think, although they misspelled Chris and Cross. So we're going to use the Criss Cross method. And what this does, this will tell us, for example, if I have two ions, we're going to use, for example, calcium, Ca plus 2, and chloride, Ca, got it, not Ca, let's fix that. Chloride is not Ca. How could it be Ca? Oops, I erased method there. There we go. Chloride is Cl with a -1 charge. So if I have two ions and I want to know what ionic compound these guys are going to do, I would follow the Criss Cross method. And it is a 3-step process, though we might only go through 2 of the steps right now. I will definitely show you a problem with the 3rd step on it. So step number 1 is we crisscross. So what does it mean when you crisscross? Well, we're going to take, what are we crisscrossing? We're going to crisscross the charges. Almost left the most important part of that off. Crisscross the charges. So we're going to take that +2, and we are going to criss it over here. And we're going to cross the -1. So we're going to cross the -1 over, and it's going to go down there. So what I'm going to be left with is something that looks like this. It's going to be Ca with a -1 as a subscript, and Cl with a +2 as a subscript. So these right here are called subscripts, and you have undoubtedly seen them before. So we've taken superscripts and we have made them into subscripts, and you've seen these before, right? You've seen them in H2O, you've seen them in CO2, which you would have seen in biology or maybe even an earlier science class, right? And what are these subscripts supposed to indicate? Well, right now they don't indicate anything. All right, right now they are wrong because that is only step 1. Step 1 is to crisscross. Step 2 is to drop the charges. And what do I mean by dropping the charges? Well, here I mean instead of having charges, what I want to have, I'm going to bring this down like this right here, is I want to change that -1 into a regular 1. It's just a regular old 1. The Cl2, the Cl has a +2 on it. We want to make that into a 2. So step 2 is we drop the charges. Step 3 can be the most difficult, or it can be the easiest. We simplify. And remember, whenever you simplify, you're either going to get rid of the 1s, doggone it. So get rid of 1, or we are going to divide. Or sometimes you won't do either of those things. Those get fun right there. So right here, this 1 is wrong, okay? In subscripts, we don't worry about writing 1. Just like if you were in math class and you wrote 1x, and your math teacher might circle that and then draw a frowny face next to it and say, no, right? I know that's what my math teacher would do, right? They'd say, no, you do not write the 1 in front of the 1x. Similarly, we don't write a 1 as a subscript, okay? So what we're going to do here is we're going to take that 1 and we're just going to get rid of it. It's already understood that there is a 1 there whenever we write it this way, Cl2. So we understood oops, understood to be a 1. Cool. That is the correct answer. Of course, I'm going to make my 2 a little bit better there. Make that a little bit better there. So CaCl2 looks like that right there. All right. Wouldn't be much one if I didn't give you another problem. What I'm going to do is I'm usually not going to give you the 2 ions. I'm going to give you the names of ions. So, for example, I'm going to give you the name of the compound. All right, so let's give you the name of a compound. I'm trying to find a good spot to do this. Here's a great spot to do this. So let's look at this one. Let's do this one. We are going to do chromium IV oxide. I want you to try and write the formula of that. By the way, good time to pause the video was back there. If you haven't, do it now. All right, now that you're back, you paused it and you tried this out. I hope you did. Chromium 4 oxide. All right, so the first thing I need to do is I need to write the ions here. That's something we already practiced last night. So chromium is Cr. It's this element right here. And I already know what the charge of it is because it gave it to me right here. This VIV is the Roman numeral 4. That means this chromium is a +4. Oxide, oops, need to scroll up just a little bit. Didn't realize that was pinched off there. There is oxide, that is oxygen. I need to know what the charge is of that oxygen. Well, remember, because it ends in IDE, I can go up here, I can look up at its root number, which is 16. 16 minus 18 gives me a -2. Right, we're going to put that one in there. So there's that -2. All right, now that I've got these guys, I am ready to crisscross. Let's crisscross. They'll make you jump, jump. So we're going to take the +4, move it down, take the -2, move that down. And I'm left with Cr, -2, O, +4. All right, next we drop the charges. Drop that charge, and I'm left with Cr2O4. Last but not least, we are going to simplify. All right, so this time I don't have a 1, so the assumption here is I should be able to divide one of these, and sure enough, 4 is divisible by 2. So we're going to do this number right here, and we're going to see, we're going to be left, that one's going to cancel out, that one's going to become a 2, and so I'm left with Cr. I'm not going to write the 1, O2. That's what you got. Pat yourself on the back. Next up is, how do you go backwards? How do you write the name given the formula?